Hi everyone. In this video I'm going to demonstrate an approach that I've come up with that will allow you to test a mediation model in Stata where that model includes a single continuous mediating variable and a binary dependent variable. Now the approach that I'm talking about is based off of some code that I've written into a do file, and with some fairly minor modifications to that do file you should be able to carry out your own analysis with your own data. So before I get started with this presentation, I do want to mention that you can obtain a copy of that do file by following the link that's provided underneath the video description, and it's going to be this do file that I reference throughout this video presentation. You will also find under the video description a link to the Stata data file that I'm working from, as well as a link to a supplemental PowerPoint. So in this presentation we are going to be running analyses involving two models, and basically the second model is just an extension of the first one. So let's start off by considering the first model. So here we have a simple mediation model, and the variables in the data are based off of some data that I collected years ago. And the data set actually incorporated a number of individual difference variables. And what we're going to be working with are three different measures. The first one is external political efficacy, which is going to serve as the independent variable in the model. We have political interest serving as the mediating variable. And then we have this indicator variable right here, donate. So it's a binary dependent variable. And this variable indicates whether a person reported having donated or not donated to a political cause in the previous year. So this binary DV is coded 0 to indicate that the person did not donate to a political cause, or 1 that indicates that a person did donate to a political cause. Now, very briefly, just keep in mind that the overall mediation model, where we have path A, path B, and path C, which are all reflecting direct effects, these paths are estimated through two regression models. So model 1 is a least squares regression where we are predicting the mediating variable from the independent variable right here. So that's where we are estimating the coefficient for path A. Then the second model is a binary logistic regression predicting the dependent variable. So in this case we have the direct effect of political interest on donate, and we also have the direct effect of external political efficacy on donate right there. And so in this case we are estimating paths B and C, which those coefficients are would be provided in the path above. So the indirect effect, which is used to evaluate mediation, is computed as a product of paths A and B. Okay, so now we are back into Stata, and I've also pulled the data into the program. So you can see right here we've got our variable list where we have donate, we've got political interest, and we've got external political efficacy right here. We also have three other variables that we'll be including in the second demonstration. So we're basically ready to use the do file that I've written, and so basically all you need to do is to open up or click on the icon for the do file editor and then find that do file on your computer. So I'm going to go under File, Open right here, and I have a copy of this under my downloads folder, or in my downloads folder. So it's called Do File for Testing a Single Mediator Model Involving Binary Dependent Variables. So I'm going to click on Open, and so you'll notice that there's a lot of information that's provided up front. So everything, a lot of the informational stuff is basically, it's all shown in green. So you can see there's a general information section right here, the how to use the file right here. And as you scroll on down, you'll see that we come to a section where we actually make changes. So this is the only section that that we're going to be making changes to in this demonstration. And I would encourage you, if you don't know much about coding and so forth, to avoid trying to make any kind of changes in other sections. But nevertheless, you can see in this section it says enter your model specifications and options. Again, do not change other sections of the do file. So in lines 90 through 92, what we're going to be doing is creating new variables from the original variables in our data set. So you can see it says generate IV equals and then the name of my independent variable. So IV is just a stand-in or placeholder for independent variable EPE, or external political efficacy. Then it says generate med right here equals and then the name of the mediating variable, and then generate dv right here and the name of our dependent variable that's given. So when we scroll down a little bit further, you'll see on line 96 it says global coves equal, and then you can see I've got two quotation marks. So if you have any covariates that you want to include in your model, you'll put the variable names in between those two quotation marks. But since I'm not incorporating any covariates in this model, we're just going to leave it empty. If we scroll down a little bit further, you'll see on line 105 we have global reps equals 50. So this is basically pertaining to the number of bootstrap replications. And so what's going to happen is that in order to test the indirect effect associated with our model, we're going to be generating bootstrap confidence intervals around that particular estimate that's created, and so we're going to be using those confidence intervals to test for statistical significance. So the default for this presentation is set at 50. This is a very low number. It's not something you should be using in real practice. Really, you want to use a much larger number, such as 1,000 or 2,000 or perhaps more. But I've got this set very low just to reduce the amount of processing time as we go through this presentation. So you'll see then on line 109 it says global diagnostics equals 1. So basically the reason why this is here is to provide diagnostic measures related to those two regression models, those submodels if you will, that comprise the overall mediation model. So I'm asked on occasion about assumptions related to the mediation model, and so there are assumptions related to the model specification and so forth, but there's also assumptions related to the individual regression models, the least squares regression and the logistic regression. So if you want some diagnostics related to those, you can set this at 1, or you can set it at 0 if you don't want that information. The diagnostics that I'm including in this are not designed to be exhaustive, but they are designed to provide some information that you might find helpful in terms of looking at those regression models. So at any rate, at this point we set diagnostics equal to 0, and so now we're ready to go. So that's basically all there is to it in terms of making changes to this do file. So at this point I'm going to click on execute selection or execute the do file. And so then it's going to run. So we'll scroll up to the top up here, and as you scroll down a little bit you're going to see a lot of the code that is already incorporated in the do file. But you'll see first off we've got equation 1, multiple regression with mediator regressed onto IV and covariates. So there are no covariates in this particular model, so what this is going to boil down to is a simple linear regression. And so you'll notice that in terms of the output, we've got the mediator, which was regressed onto the IV. Remember, the mediator is political interest, which was regressed onto external political efficacy. So we have our regression coefficient, there's the standard error, the t-value and p-value and so forth. So you can see that the independent variable was a positive and significant predictor of the mediator. So in other words, external political efficacy was a positive and significant predictor of political interest. We'll scroll down and you can see too underneath that table it says path A coefficient. This is it says 0.68158, and that's the same number that you have right here. So there's our path A coefficient. We have equation 2, which contains the logistic regression results, and in our output you can see that we have the DV, which was regressed onto the independent variable and the mediator right here. So again, donate was regressed onto the independent variable, which was external political efficacy, and the mediator, which is political interest. So we have our column of regression coefficients right here, and just keep in mind that the metric of the regression coefficients is in log odds. Nevertheless, kind of looking at this, you can see that the independent variable was not a significant predictor in the model, whereas the mediator was a statistically significant predictor. And when you scroll down a little bit further, you can see that it says path B coefficient. That's the path from the mediator to the dependent variable right here. So that's your 0.7085275. And then you've got path C prime coefficient right there. That's reflecting the direct effect of the independent variable on the dependent variable. So there's a value right there of 0.352, same value that's appearing in this table above. So at this point, now we can test the indirect effect of the external political efficacy on donate. So just keep in mind that what we're going to compute is the indirect effect, which is the product of paths A and B. So in the tables that are given below, you're going to see this is basically containing the bootstrap results as well as our computed indirect effect. So you're going to see up here it says bootstrap replications is 50, is noting that right there and right here as well. And so we have two tables with bootstrap results, but if you look in the table, you're going to see first off we have the computed indirect effect. So the observed coefficient in both of these tables is the same value. It's 0.482919, same value right there. And then you'll see that we've got our confidence intervals. So in the table above it says bootstrap standard error right here, and it says normal based 95% confidence interval. So we can use the confidence interval to test the statistical significance of the indirect effect. But my recommendation is to stay away from this particular approach right here and instead use either the percentile bootstrap confidence interval or bias corrected confidence interval right here. The percentile bootstrap confidence interval that you see in this row, this is the same strategy that Andrew Hayes' process macro is relying on in the formation of those confidence intervals. So irrespective of whichever approach you choose in terms of the confidence interval, the basic idea is this, that if the null indirect effect of 0 falls between the lower and the upper bound of a confidence interval, then you are going to maintain the null hypothesis and infer that the population indirect effect is equal to 0. If 0 falls outside of the lower and the upper bound, then you are going to basically deem that indirect effect as being statistically significant and infer that the population indirect effect is non-zero. So as you can see in our output, and we'll just rely on the percentile confidence interval with the lower bound of 0.2382 right there and 0.8742 right there, you can see that we would be rejecting the null and inferring that the population indirect effect is non-zero. Now when we scroll down a little bit further, you can see I've got some supplemental information that is provided. So you'll see for the first regression model, the least squares regression model, we have our standardized regression coefficient that's given right here. So if you want standardized regression coefficients, this is where you're going to find them. And also if you want odds ratios related to the logistic regression, this is where you're going to find them in this section. So you'll see right here that we have odds ratio, or a column of odds ratios for the predictors. If you scroll down a little bit further, you're also going to find a table containing descriptive statistics and also a table containing correlations among the variables, and both of these are based on the total effective sample size associated with the mediation analysis. So I do want to mention that the original data set contains 175 cases, but there's missing values on different variables for different cases. So as a result, after listwise deletion, the total effective sample size dropped from 175 to 164, which you see reflected in all these numbers. Okay, so now we're going to consider the second mediation analysis, and as I mentioned before, this is just an extension of the first one. Basically, we're adding in some covariates. So dogmatism and consideration of future consequences, these are both continuous variables, and then we have gender ID, which is a binary variable as well. And so gender ID is just a dummy coded variable where 0 indicated that a person identified as male, 1 indicates that a person identified as female. And so you can see that the covariates are predicting the mediator of political interest and the dependent variable of donate. And so this is consistent with what would happen if you were using Andrew Hayes process macro model number 4. And we can break that total model down into our two regression submodels. So the first model is an OLS regression, and you can see right here that we're predicting political interest. That's the mediator. And for model 2, which is a binary logistic regression, we are including the independent variable, the mediator, as well as the covariates predicting the donate variable. So from these two models, we can compute paths A, path B, and path C prime. And although it's not shown right here, the predictors in both of these models are correlated, or assumed to be correlated. Okay, so going back into our do file, we're just going to make a minor change, basically, where it says global coves. Now, between these two quotation marks, I'm going to type in dog, CFC, and then gender ID right there. So now we're going to be including these 3 covariates in our regression models. You'll see again global reps is set at 50. We could set this higher. Let's just say I wanted to set this at 100 instead. We can do that. And let's just say for global diagnostics, I'm going to go ahead and set this at 1 so that I can generate those regression diagnostics. So when I click execute the do file, then it takes a few seconds to run because now we have 100 bootstrap samples instead of 50. So going back to the top and kind of scrolling down through our output, you can see our equation 1 multiple regression with the mediator regressed onto the IV and the covariates. So you'll notice that we have the mediator regressed onto IV, and then the names of our covariates are appearing right here. So and as before, we have our standard regression output to evaluate the overall model and then the individual predictors. So looking at the effect of IV on the mediator, basically the effect of external political efficacy on political interest, you can see we have a positive and significant predictive relationship right there. And you can see that really none of the covariates are statistically significant at the conventional 0.05 level. And you can see below too that where it says path A coefficient is a 0.592. Again, that's the number that is appearing right here in that regression table. When we scroll down and look at the second equation, this is our logistic regression. So we've regressed the DV onto the independent variable, the mediator, and then our 3 covariates right here. And so you can see that the effect of the independent variable on the dependent variable, it's a positive value right there, positive regression slope, and we have statistical significance. The effect of the mediator, we have a positive slope, and we have statistical significance there. So you can see from those that basically the path B coefficient, which is the 0.85628, that is statistically significant. You can see the C prime path coefficient of 0.5584, that is also statistically significant. Now when we scroll down and look at our indirect effects, you can see our 2 tables containing the bootstrap results. And again, bootstrap replications, we had set this at 100, and so that's reflected in both of the tables. I'll scroll on down though, and the indirect effect, which again is computed as a product of paths A and B, is 0.5069606. And looking at the percentile bootstrap confidence interval, the 95% confidence interval, you can see that it ranges from a lower bound of 0.22425 to 0.8946. And you can see that 0, which is the null, does not fall between the lower and the upper bound. So we're going to reject the null and infer that the population indirect effect is non-zero. So looking again at the supplemental results, you can see now we have the standardized coefficients for the independent variable as well as the covariates for that first regression model. And when we scroll down, you can see that we get the odds ratios for the independent variable, the mediator, and the covariates for this logistic regression model. Scrolling down a little bit further, you can see that we have our descriptive statistics and correlations among our variables based on the total effective sample size. So in the next section, because we had requested the diagnostics, we have various diagnostics for the first regression model, the least squares regression model, and then also for the logistic regression. And I do want to reiterate, these are not exhaustive, but they do provide some general information that you might find useful. So just briefly, just kind of taking a look at what is available. I'm not going to go into all of the depth related to these, but just kind of note that included in the output is the Pagan test and White's test. Both of these are used to test for heteroscedasticity of the residuals. So the null hypothesis for both of those tests is that you have homoscedasticity or constant variance. And so if you reject the null in either of those cases, then that's going to be an indication that you have a violation of the assumption of homoscedasticity. Now if we scroll down a little bit further, you can see that I also have collinearity diagnostics related to the least squares regression model, or basically model 1. So you can see that I've got a column of variance inflation factor values as well as tolerance values right there. So if we scroll down a little bit further, you can also see that we have skewness and kurtosis related to the residuals, as well as skewness and kurtosis tests for normality related to the residuals. Additionally, I've included some output where cases with studentized residuals that are greater than or equal to 3 are listed. So you can see in this output that we have only one case. That's case number 95 with a studentized residual that exceeds that threshold. Finally, you can see that we have Cook's D values that are given, but these are the most extreme Cook's D values using this formula right here that's taken from the post-estimation commands PDF from the Stata manual. So if we go down a little bit further, you can see that I've got regression diagnostics for the logistic regression. This is our model 2. Again, we've got variance inflation factor values and tolerance values that are given. If we scroll down a little bit further, we've got basically Pearson residuals. So those cases with Pearson's residuals that are greater than 2.5 are provided in this table right here. So you can use those to identify potential outliers. And then finally, if we scroll down a little bit further, we have output containing Pagan D betas or D beta values to identify cases that may be exerting undue influence on the logistic regression model parameters. So in other words, these values are kind of functioning similar to what we would use with or function similar to kind of Cook's D and the DF betas in the context of least squares regression. So one other thing to note is the output contains a scatter plot where we have Pagan's D betas plotted against the predicted probabilities from the logistic regression. That's in the upper portion of the output or the graph, and then in the lower portion we have a plot of the Pagan's D betas against the case ID. So basically this is an index plot. So you can use those in conjunction with the values that are provided in this table in order to identify potential influential cases. Okay, so that pretty well wraps up this video presentation, and I appreciate you watching.